So hi guys, today is the day 14 of our doing Leetcode daily until I get a job. So let's start with the questions, and we have graph questions. So first question is this: Pacific Atlantic water flow. So what it says is that this is a Ambayan rectangular island that borders both the Pacific Ocean and Atlantic Ocean. The Pacific touches the island's left and top edges, and the Atlantic touches island's right and bottom edges. So this is Pacific and this is Atlantic. Okay. So the island is partitioned into a grid of square cells where Ramayan and integer matrix heights and height RC represent the height above the sea level of the cell of the coordinate RC. The island receive a lot of rain and the rain water cannot flow to neighboring cells directly north or south or east or west. Yeah, so it's obvious that if the height of the adjacent is less than the current cell, then only the water will flow from there to there. So return a 2D list of grid coordinates which consist of result RC denotes the rainwater can flow from this row column from this cell to both Atlantic and Pacific Ocean. So basically we need to find the cells from where the water can flow to both the oceans, right? Like if we take this corner, obviously from here, whatever its side doesn't matter, it will flow to both of these oceans. If from this side also, how will from this side water will flow? Water can flow from here to here, and from here to here to Pacific and Atlantic it can directly flow. Like for this whole column, water can flow to Atlantic, and for this whole row, water can flow to Pacific. For this whole column, water can flow to Pacific, and for the last row, water can flow to Atlantic directly. Okay. So, we can just, for each cell, there are two things. Can the water flow to ocean Pacific? Can the water flow to Atlantic from this cell? Okay, so we can take basically uh, two Boolean vectors, and one for each Pacific and Atlantic, one for each ocean, and for each cell it will be two values, true or false, for both the oceans. And if the value is true for both the oceans at that cell, means the water can flow from there. Okay, so what we will initially do is that, yeah, that way we'll memorize the result also, that if um, uh, a cell is marked true already, we won't be visiting it again, right? If the cell is marked true, it means that we have visited it. We will just return from there and will not compute the adjacent of it again. So, and also for one cell, we will go to all of its adjacent cells. See, we will do the DFS because that seems simple here, that at any cell, let's say we are at 3, we will go to all the 4 directions: top, left, right and bottom. And wherever the height is less than the current cell, like less than 3, wherever the heights are, like this side height is 2 and this side height is 2, this side we won't go, this side we won't go, so only this side water can go, so we'll go to 2 and then we will go to this 2, and we will search for this 2 from this 2, that where we can go. If it goes to a cell which is true, if it is redirecting to us to a cell which is true, it will return true, this path will return true, and ultimately 3 will be returned Pacific true, that it from here water can flow to Pacific from directly here. And can the water flow to Atlantic from here? Then we'll check from 3, we'll go this way. Now this cannot lead to this way. Can this lead to this way? No, no. So water cannot flow to Atlantic from here. So it will return a false, that water cannot flow to both the ocean from this cell. So this is basically what's our approach going to be look like. Okay, so now we can start solving it. Let's firstly take the let's take it as h. Won't be writing heights again and again. H dot size, and n is equal to h0 dot size. Okay, now let's take boolean vectors, 2D boolean vectors actually, to store the result of Pacific. It will be initially m and all false. false. Okay, so it will be, and the size is n here for all the columns. Okay, and we will just copy this same thing and paste it out for Atlantic, and here will be n, and here we will have n. Okay, you have created the visited vectors for both of them. Now let us do one thing. All these four, like all the boundaries, let's just make the boundaries true for whatever ocean they are touching. So let's say we are taking the columns first, these two columns. Okay, uh, this column and this column, first and last columns. So I is equal to 0 to I is less than, we'll go to each row, that will be m. Okay, m, and I plus plus. So we will just do what for the first column. So for the first column in Pacific Ocean it is touching, right? So for the first column is row is fixed, row is changing, and column is fixed. First column we will just put true, and for the last column of each row, that is Atlantic Ocean it is touching, so that will be n minus 1, it will be true. Okay, and we are gonna do this same for first and last row also. I is equal to 0 to n, first to last column, and in each column first element and last element. So this will be now 0, and this will be I, this will be m minus 1, and this will be 0. Okay, so we did this. Now after doing this we will go to each character. Let's say this is our answer. Vector, 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 yeah, int. Well, this is our answer. We'll loop through the whole grid now. I is equal to 0 to I less than m I plus plus, and j 0 to j less than n j plus plus. Okay, and we will check if the function dfs is true for Pacific at I and j, and we have the heights array here. Okay, if it is true for Pacific, this cell is true for Pacific. Okay, at 6 it will start. Okay, so I have some work at 6, so I will try to finish it as soon as possible. So it will be Pacific, and we have to do the same for Atlantic, H. If they both are true, then it will return, so sorry, answer dot pushback, it will I j, correct, and we will just return the answer. So this means that if the water flow to Pacific as well as Atlantic from the I and J, I row and J column, this cell, then it will be true, and we will push back it in the answer. So how will we check? We'll check in such a way. See, firstly we will have the vector of Boolean like this. I will name it as let's say ocean, obviously, and will be here, right? Yeah, I guess. And then the two variables, well, int I, int j, and this heights vector, so it will be height vector. Yeah, so first thing, if I is less than, because we will be doing recursion in all the directions, so that's why I'm writing the stopping condition right before that. I is less than 0, or j is less than 0, or I is equal to h dot size, or j is equal to h 0 dot size dot size, or yeah, okay. In this case we will return false, that water will not flow there. If this result is already calculated for this ocean, we will just return true, that it is has been calculated. And it's if it's true, okay, if it's true only then. Obviously if it's visited it will be true. Then um, what we will do is we will go to all the four directions. But firstly, let's take the what is the height of the current cell, that is h, I and j. Okay, we store the height of the current cell, and let's make the height of the current cell something which we can track, right? Like the maximum height can be 10 raised to the power 5. So we will make this like 10001. Okay, this will work. That we will make it this, like if this is, and we will add a condition here that if the current height is if this, then we'll return false, that this height is something which we cannot, obviously which will not be getting. And it's if it's this, like we don't want to return to current cell. Okay, that's why we are doing this. That's the whole purpose of this. And now we will take a flag and we'll do it false. Why we're taking it, we'll see in a minute. So now we are going on the four directions. So how we can go in the four directions? So if I is less than, sorry, I is greater than 0, then only we can go to I plus I minus 1, right? Then h of I minus 1 j, and only we will go to I minus 1th direction, means the previous row, when it is less than the current height, and current height is ht. If it is only less or equal to ht, then we will go there, and our flag will be flag or whatever DFS will return, that is ocean I minus 1 j and h. So what does this mean is that if the water cannot go to the I minus 1 j cell, it will return false. So false or false, it will stay false, that in this direction we got a false. If this returns a true, then it will be true or false, because it is initially false, so it will be true. Okay, so that similarly we will be doing this for all the four directions. And second will be taking it as 0, j is greater than 0, and we'll shift this minus 1 to here, and we will shift this minus 1 to here. Similarly, if I is less than n minus 1, only then we can go one step further, right? N minus 1 is not given, so it will be like h dot size minus 1 less, okay, then it go to only there, and it will be plus 1, and it will be plus 1. Same thing we're gonna do here for j, is that if j is less than h0 dot size minus 1, okay, that will be a dot, not comma, and it will be j plus 1, and it will be j plus 1. Okay, so if after all doing all this thing, see, if we get a boolean value true, that from this cell somehow we can go to that ocean, somehow we can go to this ocean, then the flag must be true. And if the flag is true, so the we can put out as this is flag. If it's true or false, doesn't matter, whatever it is, flag. Okay, then we will assign the original height to the I and jth index, that is ht, and we will return flag. We are returning the flag and we are saving the flag here because it will be so that we don't have to visit it again and again. So I think this makes sense. And j is greater than 0. What's missing here? Okay, it is not, it should not be outside. It must be here and it must be a for loop. Fine. Yeah, this is correct. And okay, we have a problem here that Atlantic int I 0, so int I less than m. We are going to each row and
ये ना खाया तूने
खा लूँगा हाँ.
आलू गोभी आलू गाजर
Okay, so this seems n minus 1. N is at 0 dot size, okay. M is the number of rows, N is the number of columns. If they both are fine, yeah. Then Atlantic I, how is it? But these vectors are messing around. So the vector is same, right? M by N. So we should not mess with this. We're just taking these same size vectors at height, just for Pacific and Atlantic Boolean values. Okay, so it should be the same. Yeah, fine. Perfect, not perfect. Well, that's it. Okay, let's try to debug it. So we are taking here the boolean values, boolean vectors to save. Let me take the, yeah, okay, to save it. Fine. After that we have these two for loops, correct? And this completely makes sense why we are doing this. And less than m, and n minus 1, and n m minus 1 here. Perfect, not a problem at all. After that we are storing the answer here, and for I and j and m j 0 to n, let me check the loops. Okay, ij dfs at Pacific and Atlantic both, if they are true, then we'll push back the answer. Okay, so now let's go to the dfs. Okay, so in the dfs here, if I is less than 0, okay, I is equal to h dot size, or j is equal to h0 dot size, or ht is equal to this height, then we just return false. Perfect. Yeah, we'll return false if any of this is true. I is equal to h, right? J is equal to h0 dot size, ij. Okay. Ocean ij is true, then we will just return to that it is already calculated. We will ht is equal to hij. Hij will be this. We'll take a boolean flag. Okay, and we will go to all the four directions. First direction, if I is greater than 0, then we will go to hi minus 1. Okay, then we will go to hi minus 1, and if it is less than k, then only we will go for this. If it is less than height, then we will go for I minus 1. Next is dfs ocean. Okay, I minus 1, j minus 1, I plus 1, j plus 1. Perfect. If h dot I is less than h dot size minus 1, yeah, yeah, perfect. If I is less than h dot size minus 1 and I plus hi plus 1j is less than height, then we will do this and then we will do this. Yeah, we're comparing it j, fine, hi j plus 1 less than height. Okay, then put it as a flag. uh, HG and return the flag. It's perfectly fine, but I don't see where the problem is. These are all small values, no large values there. Then what might be causing the problem here? What might be causing the problem here? IG. I is the row, J is the column, correct? I is the row, J is the column. Push back IG. Why is 11 and 3 pushed here? See 11 and 3. Plus equivalent plus equivalent. I0 I n minus 1 0 I n minus 1 0. Oh wait, m minus 1 0. No, it should be I here. Okay, fine. I think we got the problem here. Yeah, perfect. Okay, just let's shift to the next question. That is a course schedule. Course schedule, I remember this question, and this is a topographical short question as far as I remember. Basically, this number of courses, num courses you have to take and label from 0 to num courses minus 1. You are given array prerequisites where prerequisites I is A and B indicates that you must take course B first if you want to take a course A. So 0 1 0 means for taking 1 we should take first 0. Okay, so we can take an example of this, like basically the thing is that let's say 4 courses are there, 0 1 2 and 3. Okay, and we form a thing like 0 1 2 and 3. These are the 4 courses. Now we are given that for taking 0th course we must complete 1 first. Okay, so 1 must be completed before A. We will make the graph data structure like this. Okay, so 1 should be completed first, then 0. Okay, similarly one other dependency is that for completing 2 we have to complete 3 first. So for 3 completing 3, 2 must be completed first. Okay, and for completing 3 we must complete 1 first. Okay, and for completing 2 we must completing 0 first also. So let's say these are the dependencies. First thing, now if you go through the BFS solution, there is the topographical sort solution. We can see that the course with in degree 0 means there is no incoming edges to that node. That node have no dependency. We can complete that course without any dependency, right? So we will complete the course with the 0 in degree first. Let's say we complete first. Now if this is completed, one dependency of 0 is removed, one dependency of 3 is removed. Okay, now both has 0 in degree. We can take any of one of them first. Let's say we take 3 first, then 3 is completed, then one dependency completed. Then we can take 0 because it also do not have any dependency, so it will be complete. Then 2 have 0 dependency. All dependencies are sorted. So this is how we complete this course. And by DFS the solution will be like, if this kind of structure we form with the help of the given data, if this contains a cycle, then we cannot complete all the courses. Let's take like one depends, one must be completed before 2, 2 must be completed before 3, and 3 must be completed before 1. If there's such a structure, then there's a cycle. Nobody can start and complete. Okay, everything depends on each other. So this basically forms a deadlock kind of structure. So that's why it cannot be completed. So we can do this by both BFS and DFS. By BFX, it will be see that there's no node within degree 0. Everyone have some dependency. So nothing can be started to finish. Okay, so it will be another answer, right? So we will just go with it. Let's me check the video. Yeah, it's fine, 25 minutes. Okay, so course schedule 1, we can start with the BFS solution, because the BFS solution seems kind of, because the topological sort is a really good pattern, one of the good pattern in solving the graph question. So let's practice this. We have done enough DFS question, and we will approach the DFS also later once we complete this BFS. So let's start with this. Firstly, we have to make a adjacency list. If you don't know about adjacency list, I recommend to search and read about that. It's a kind of a representation of graph data structure. Okay, if we're given a graph, then it could be represented as a adjacency list to reduce the complexity of readability. Actually, that it seems simple when we have a adjacency list. It's simple to work with it. Okay, so let's do it num, and let's name it pre. Okay, adjacency list will have a size of n. It basically represents vector of vector means uh, for cos 0, what are the dependencies? It will form a vector corresponding to 0. Okay, so it basically is that. So we will do what is, we will form the adjacency list, and we will also take a vector of n degree, and n degree will have a size of n, and initially everyone have a 0 in degree. So let's form the adjacency list. So for auto it of the prerequisites, we will see what if we are given 1 0, that means 0 must be completed first and then we should go to 1, because to take course 0 we must take course 1. 0 1 means that. So we will take 1, will make the arrow 1 to 0. Here we will make the arrow 0 to 1. So we will do what is that, git of 1 dot pushback it 0. Okay, and in degree of it 0 will be increased. it 0, because the arrow is going from it 1 to it 0. Okay, so this is how we form the adjacency list, and we have the count of in degree for each of the nodes. Okay, so now let's take our answer as 0. This is what answer suggests, actually the number of courses we are completing. Okay, and if it's equals to this n, the number of total courses, then we are good, we can return true. So now we will check for the nodes which have a in degree of 0. Okay, so let's take a q. We will see now how this question becomes an easy question now. So for int I 0 to I less than n I plus plus, we will search for the elements if we have a whichever in degree of 0. If in degree of I is 0, we will push it to q dot push that node. Okay, from that node we will be starting our BFS. Okay, and we will increase the answer by 1, because whatever course have in degree 0 means that can be completed, and that will increment our count to 1. That will increment our count every time we find a node with 0 in degree, because that can be completed. And if the total number completed equals to n, then we are done. Okay, it will increase our answer. So now we will start traversing the queue. So while queue is not empty, we are gonna run this loop. And what are we going to do here is we will just take the f as q dot front. We will q dot pop it, and then we will go to the adjacency list of this front. For auto adjacency list of this front means g of this front. Okay, we'll go there and we'll see in the adjacency list of this front, because we have completed this course, and whoever was dependent on this course now have one less dependency, because this course is done. So if something depends on this course, they can remove it as the dependency. It is completed. Okay, and if in the adjacency list we will decrement the in degree of every adjacency element, right? Because that course is now completed, so we can decrease the adjacency degree of the neighbor nodes. Okay, like if we complete the 0 here, we can decrement the degree of 0 and 3 by 1, because they both depends on it. And if this is done, the degree can be reduced by 1. Okay, so it is reduced by 1. And if now the degree of this element becomes 0, then we can push it to q dot push this element, and we will increment the answer. Okay, this is how it works. And if now return, we just have to check if our answer is equal to the number of total courses, then we are good. If not, then the course cannot be completed. All the courses. Okay, we'll submit it. So yeah, you can see that this was a really simple question. And now the course schedule 2 is, there were a total of number courses same. Okay, what else we need to do here is that return the ordering of courses you should take to finish all the courses. So now we have to give the order in which we will be finishing the courses. So can it be more simple? Because with this approach, that question can be done in the same way. Like obviously, in the same way, whichever element has the in degree 0, that can be completed first. So here, what will be the order? We have a in degree, which element has in degree 0 initially? 1. 1 will be completed first, then 0 or 3, any one of them, then 2. So its answer will be 1032 or 1302. Anybody of the answer can be taken, and it will be just fine. Okay, so what we can do here is that we can, instead of this answer, we can take a vector. No, let's take this answer also, and let's form this res. Okay, so every time we pop something, we will just push it into our vector. Let's use the final answer. So res dot push back f. Okay, it will do the same thing. And if n is equal to answer, means all can be completed, then we will return answer, else we will return an empty array, because it's given that it's impossible to finish all courses, return an empty array. Okay, so yeah, that should do the thing. Error initializer list cannot be used on right hand side of the operator. Initializing list, it's initializing a list, seriously? Okay, let's do it like this. If n is equal to answer, we can just return res, else return an empty array. Fine, this should work. Okay, return res, all conversion return type vector into bool. Course schedule 2 should return bool here. Hello. So there was a really I don't know what kind of mistake this is, but we are not writing the same function. We just copied the whole code from the previous question. That's why the problem was happening. That return type was boolean, and this is function name was also different, so that's why it's giving the error. Otherwise this question is already done, and yeah, it's done. So these three questions are I guess I could do more, but that's enough for today because I have some work to do. So yeah, that's it for today. So we will continue this series from tomorrow, and we will do more questions from it. I Yeah, so okay, I skipped this question. I don't know this. I just missed it. Surrounding region. So we will do all these three questions tomorrow, and we'll complete the this series of drafts, and we'll start DP from next day. Okay. So yeah, that's it for today, and we'll meet tomorrow. Bye.